Hi there, welcome to the Math 60 lecture for section 2.2. In this section, we are solving multi-step linear inequalities. In this section, I want you to keep in mind that picture I drew in the very first video about someone learning or exploring a mathematical landscape, how they learn a little bit here and learn a little bit there, and then they're asked to learn something new. Well, that's exactly what's going on here. We've talked about solving multi-step equations, and we've talked about inequalities, and now we're just going to put those two ideas together and solve some multi-step linear inequalities. So 90% of what you're doing, you've already done in some way, but you're just going to put it together in a slightly new way and add a little bit more on top of that. And again, this idea is going to come back again and again in the course. I do teach solving multi-step linear inequalities a little bit differently than what's in your textbook, so keep that in mind. Let's solve 3x minus 2 is less than negative 14. Now, when I think about this picture over here, I think, okay, I've worked with inequalities and I've solved multi-step equalities before. So the first thing I'm going to do is I'm going to say, I'm going to do something that I know how to do. I'm going to change this into an equality. I'm just going to rewrite it, and I'm going to say, I don't want to solve the inequality yet. I'm going to solve the equality. Why? Because I've done that before, because I'm confident with that. Because if there are tricky things in the inequality, at least there probably won't be any tricky things in the equality because I've practiced that a lot more. So when we solve that, let's add 2 to both sides, and we get 3x equals negative 12, and divide both sides by 3, and we get x equals negative 4. So I haven't solved my original question, but the equality was fairly easy to solve, and that gives me some confidence. My next step is I'm going to draw a number line, right? I'm going to use the graphical representation to help me. Here's 0, here's negative 4. Now, when we solve the equality, what we found was the end point of an interval. Remember, when we talk about inequalities, we're talking about intervals with endpoints. And the endpoint is where it's equal. We've drawn a number line and we put our endpoint on there. Sometimes, especially in the future, you may have more than one endpoint. And that's why number line is really helpful for you to keep track of it all. The next thing we need to do is we need to decide which side of the endpoint is in the interval. If negative 4 is the endpoint, then it could be everything less than negative 4, or it could be everything greater than negative 4. And the easiest way to do that is just by testing a point. Now, that's very similar to checking your solution when solving an equality. But instead of checking the solution, I'm just going to check a point that's not the solution. We're going to check points on either side. Now that I'm saying this, I think I actually might have done it in an earlier video, but I'll just do it again. So let's check a point less than negative 4. Negative 5 is a pretty easy number to check. And we're going to check it in the original formula, 3x minus 2. So I have 3 times minus 5 minus 2. Let's see, and that's negative 15 minus 2, which is negative 17. Negative 17 is less than negative 14, and it's supposed to be less than negative 14. So this works. So x equals negative 5 works in the solution, right? It's a possible solution. Well, if x equals minus 5 works, then that point works, and that means because we're an interval, all of those points work. We should be able to get away without checking the other side because we know that negative 4 is an endpoint, but let's test it just in case. Also, it's really easy to check because 0 is a number. And that makes our work really fast. 3 times 0 minus 2 is 0 minus 2, which is negative 2. That is not less than negative 14. So x equals 0 is not in the solution set. And the last step is to decide if the endpoint itself is included. We could have decided that earlier, but I tend to do it at the end, and that's fine. By checking the inequality symbol. Right? A less than means exclude the endpoint, or a greater than. And a greater than or equal or a less than an equal means include the endpoint. The formula was a strict less than, so I'm going to exclude the endpoint. So here I'll draw my parentheses, my open parentheses, and there's my solution set. And so now we can write it as an inequality or set builder or interval, however you want. I'll write it this time as a set builder. This is x such that x is strictly less than negative 4. So the new part here was testing points. You've already solved multi-step equations. You've already drawn number lines. Now we test a point, and we've already done intervals as inequalities, set builders, or interval notation. This becomes really powerful when your inequalities get much more complicated. Your book's going to talk about switching the direction of the inequality sign. You don't have to worry about any of that as long as you solve the equality first and then test points. Someday you'll be taking a math class, and what you're going to find is that your solution set, this is just a look ahead, has a bunch of different points on there. And you're going to have to decide, is this interval part of the solution? What about this one? What about this one? What about this one, or this one, or this one? And testing points is a much easier process than anything else. All right, that wraps up this video, and I'll see you in the next one. Thanks for watching.